Namaste everyone and welcome back to our channel. Today, we are diving deep into a super important and exciting topic in Spring Framework, Spring Async and the powerful @async annotation. Have you ever wondered how to make your Java applications run tasks in the background without blocking the main flow? Well, that is exactly what asynchronous programming helps us achieve, and Spring makes it incredibly easy with @async. By the end of this 5-minute tutorial, you will understand what asynchronous programming is, how to implement it using Spring's @async, and even some best practices to avoid common pitfalls. So, grab your virtual notebooks and let us get started on this amazing journey to build more responsive and efficient applications. Alright, let us understand the fundamental difference between synchronous and asynchronous execution. Imagine you are at a coffee shop. In a synchronous world, you order your coffee and then you stand there waiting for your coffee to be prepared, and only after it is ready do you move on to your next task, like paying. Your entire process is blocked until the coffee is served. Now, in an asynchronous world, you order your coffee, but then you immediately move to the side to check your phone or do something else while your coffee is being prepared. You are not blocked. The coffee preparation happens in the background, and you get a notification when it is ready. This is the essence of asynchronous programming. Tasks run independently, allowing your main application thread to continue its work without waiting. Spring's @async annotation helps us achieve this easily by executing methods in a separate thread pool. Now, how do we actually enable and use this magic @async annotation in our Spring application? There are two main steps, my friends. First, you need to tell Spring that you intend to use asynchronous capabilities. You do this by adding the @enableAsync annotation to one of your Spring configuration classes, typically your main application class or a dedicated configuration class. This annotation activates Spring's asynchronous processing power. Second, to make a specific method run asynchronously, you simply annotate that method with @async. When this @async method is called, Spring intercepts the call and executes it in a separate thread from its managed thread pool. Remember, for @async to work, the method must be public and it must be called from a different Spring managed component, not from within the same object, which is a common mistake we will discuss later. Let us put our knowledge into practice with a real-world example. Imagine we have a service that simulates sending an email, which is a common long-running operation. Here, we have a mail service with a method called sendEmail. Without @async calling, this method would block our main application. But by simply adding @async to the sendEmail method and enabling @enableAsync in our main application, this method will now execute in the background. Our main method can call sendEmail and immediately proceed to print main thread continues, without waiting for the email simulation to complete. You will see the output demonstrating that main thread continues appears before email sent, even though email sent was called first. This clearly shows the non-blocking nature of asynchronous execution, making our application much more responsive. While @async is incredibly powerful, there are a few common mistakes and best practices to keep in mind. One common pitfall is self-invocation. If an @async method is called from another method within the same Spring Bean, the @async annotation will not work because Spring's proxy mechanism is bypassed. Always call @async methods from different beans. Another important tip: if your asynchronous method needs to return a result, make sure its return type is java.util.concurrent.future. This future object allows you to retrieve the result or check the status of the asynchronous computation later. Also, consider handling exceptions within your @async methods or configuring an async exception handler. Finally, for production applications, it is often wise to configure a custom task executor to control the thread pool size and behavior, giving you more granular control over your asynchronous tasks. And there you have it, my friends. We have covered the essentials of Spring Async and the @async annotation. Remember, asynchronous programming allows your application to perform tasks in the background, keeping your main thread free and your application responsive. We learned about enabling asynchronous capabilities with @enableAsync annotating methods with @async and saw a practical example of simulating a long-running task. We also discussed crucial tips like avoiding self-invocation, using future for results, and considering custom task executor configurations. Practice these concepts, try them in your own projects, and you will be building highly efficient Spring applications in no time. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more amazing Java and Spring content. Keep coding, keep learning, and I will see you in the next video. Jai Hind.